So the second part, or the second half of chapter 5 is all about solving higher degree polynomial equations. And how do we do that? We factor it. We usually factor by making it look like a standard quadratic equation, and then we factor using factoring methods. Today we're going to learn about the remainder theorem and the factor theorem. The remainder theorem simply allows you to use synthetic substitution instead of plugging in and doing math. Okay, I mean, here it is. If a polynomial p of x, which could be any degree polynomial, is divided by a binomial x minus r, so if you had like x minus 3, then your r value would actually be 3. And it says right here that the remainder is the actual answer to plugging in r into the original p of x function. I know that sounds really confusing, but let me just show you how this works. Let's divide the p of x quadratic trinomial function by this binomial x minus 3. So if I wanted to do synthetic division, what would I plug inside the box? What do I have right here? I have a 3. So instead of a box, I didn't have this symbol on my computer, I'm sorry, but that's what we have right there. You guys remember synthetic division? Yes? So we have this quadratic trinomial divided by the binomial x minus 3. So that's why I plug in a 3 right here instead of a minus 3. I always say think opposite, but the real reason why we think opposite is if this were a factor of the polynomial, then you'd be able to set it equal to 0, which would mean that you're plugging in the actual number 3. I know if that doesn't make sense, it'll make sense later. But right now, we're dividing this quadratic trinomial by this binomial, so you put in the opposite of what you see right there, 3. And as you go down, what happens? Negative 3 plus nothing, you combine it. There's nothing there. So as you go down, you combine. Negative 3 plus nothing is negative 3. As you go up, you multiply. Positive 3 times negative 3 gives us a negative 9. As you go down, you combine. 5 combined with negative 9 is what? And as you go up, you multiply. 3 times negative 4 is? Negative 12. And as you go down, you combine 4 and negative 12? Negative 8. Okay, so negative 8 is our remainder. When we divide this p of x function, negative 3x squared plus 5x plus 4, when we divide this quadratic trinomial by the binomial x minus 3, we get a remainder of negative 8. If we were to do long division, we would see that the remainder is negative 8, right? This last number is the remainder. Now, let's compare that to actually taking the answer 3 and substituting it into our function. So notice I have my p of x function up here. I just took those x's and replaced them with parentheses, and I am going to plug in 3 into the parentheses. Does that make sense? We've done this before. It's function notation. It's telling you to take 3 and plug it into your x's. In other words, they're telling you x equals 3. That's what they're telling you. So here are your x's. We're plugging in a 3 into those x's right there. So let's do that. We'll get 3, 3. And when we work this out, you go exponents first. 3 squared is 9. 9 times negative 3, that's negative 27. 5 times 3 is 15. If you go negative 27 plus 15 plus 4, you know what you're going to get? Anybody?
Negative 8.
Negative 8, the same exact answer. Okay, so what I've done here is kind of demonstrated why we are able to use synthetic substitution. Okay, the remainder theorem tells us that if a polynomial p of x is divided by a binomial, then the remainder is a constant p of r, where r would be the opposite of what you see there. I know that this is way more complicated than what it's supposed to be. It's as simple as this. You could use synthetic substitution. Just like you do synthetic division, you could use synthetic substitution instead of actual substitution. So on this problem right here, you could, if you wanted to, plug in negative 3 into all of the x's and do all that math. Or you could plug in right here the negative 3 and do the coefficients of all your terms representing every single power. Do we have every single power represented?
No.
No? What's missing? X is missing. So let's do the coefficients of all, and let's even put the 0 for that x that's missing. So give me the coefficients. 1, 2, negative 1, 1, negative 9, 0, 20. Whoops. So as you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. Negative 3 times 1 is, help me out, guys. Negative 3. Okay, and as you go down, 2 combined with negative 3, what do we get? Negative 1. As we go up, we multiply. Negative 3 times negative 1. Positive 3. As we go down, we combine. Negative 1 and 3. 2. As we go up, we multiply. Negative 3 times 2. Negative 6. As we go down, we combine. Positive 1 with negative 6. Negative 5. As we go up, we multiply. That gives us positive 15. As we go down, we combine. Negative 9 and 15. 6. As we go up, we multiply. Negative 3 times 6. Negative 18. As we go down, we combine. What's 0 plus negative 18? Negative 18 again. And then how about when I go up? Negative 3 times negative 18, what do we get?
54.
Positive 54, correct? So let's put positive 54 up here. And as we go down, what do we get? 74. Ladies and gentlemen, this is not synthetic division. This is synthetic substitution, where we plugged in the negative 3 and we got out the answer 74. So it's like an input and an output. You could, I mean, is this necessary for you to know? Are you supposed to, is this absolutely necessary for you to be able to do synthetic substitution? No. Why not? Because if you want, you could do it the old school. You could take that negative 3, put it right there, put it right there, put it over here and here and here, and then do all that math, which is going to take a lot longer. So it's not absolutely necessary, but it is very convenient to know synthetic substitution. Let's talk about the differences between synthetic division and synthetic substitution. Up here, where we did synthetic division, we had the p of x divided by x minus 3. What did we plug inside of the box? Positive 3, right? And down here, where we did synthetic substitution, what do? We plugged in that actual value, negative 3. Now, let's talk about why on synthetic division we plug in the opposite instead of the actual value. You see, the thing is this. Again, if this were a factor, you'd be able to set it equal to 0, which means when you solve it, you'd get the actual value of x equaling 3. And that is exactly why we're plugging in the opposite of what we see there, positive 3. Does that make sense? Yes. Okay. But over here, it's not in parentheses. They're just telling you, hey, plug in negative 3. All right, you plug in negative 3. So there's going to be a couple of questions on our homework that involve plugging in. All right, so number 4, go ahead and try it. You see, the thing is this. They're telling you, this notation tells you plug in 4 in place of x. Indirectly, what they're telling you is, hey, x equals 4. That's what they're telling you. So wherever you have x's at, you have to plug in the 4. That's regular substitution. But a quicker way of regular substitution is synthetic substitution, where you plug in that 4 value and you just do a list of your coefficients. Do we have any terms that are missing? No, so let's just write out the coefficients. The coefficient of x to the third is 1. Coefficient of x squared is 3. Coefficient of x is 2. Coefficient, or actually the constant at the very end is negative 50. And let's do synthetic substitution. The 1 comes down. That's just a 1 down there. Then you multiply as you go up. 4 times 1 is 4. As you go down, you combine. 3 plus 4 is 7. As you go up, you multiply. 4 times 7 is? Anybody? 28. Thank you. Stay with me. 2 plus 28? 30. Okay. As I go up, I'm going to multiply. 4 times 30? 120. And if this were synthetic division, this would be my remainder, but it's not a remainder. This is actually the answer because you're substituting, right? So when you plug in a 4, you get out a 70. It's an input of 4 giving you the output of 70. Technically, it's a coordinate 470 on the graph of this cubic polynomial function. Anyway, that's just a quicker way of substituting, but you don't have to use this quicker way. You could do the old school way of plugging in. I mean, I could actually plug in a 4 right here. 4 to the third is 64, and then 4 times, or 4 to the second, 16, 3 times 16. Oh, forget it. It's just easier to do this, right? But if you wanted to, you could do it the old way. So is this essential? No, it's not. But check this out. Over here, the factor theorem. This one's a really important theorem. By the way, theorems in math are the truths about math, right? So this theorem is a truth involving factors, okay? Here's the factor theorem. The binomial x minus r is a factor of the polynomial p of x if and only if p of r equals 0. What does that mean, p of r equals 0? If your remainder is 0, then it is a factor. Okay, so a lot of us are thinking, what the heck did he just read? I don't understand that. And the phone's ringing. Check it out. Let's make this a little more understandable. What if I asked you, is 5 a factor of 12? Is 5 a factor of 12? No. Is 4 a factor of 12? Yes. Now, if I said again, is 4 a factor of 12? Yeah, 4 goes into 12 3 times. What would your remainder be? 0. Okay. Is 5 a factor of 12? No, because when you do this, you're going to have a remainder. So it's just simple. If you're dividing something by a factor of that something, the remainder should be 0. Does that make sense? If you're dividing something by a factor of that something, the remainder should be 0. Is 4 a factor of 12? Yeah, because the remainder is 0. It goes into 12 3 times perfectly. There is no remainder. So that's what the factor theorem is. It tells you that this binomial right here, the x minus r, that will be a factor if and only if your remainder is 0. And it's totally clear when you do it with simple numbers. 4 is a factor of 12. Why? Because the remainder is 0. 5 is not a factor of 12 because you actually get a remainder. So in order for something to be a factor of something else, you have to be able to divide that something else by that binomial, and the remainder should be 0. Is that clear to you guys, what I'm saying? Yeah. Okay, maybe after this first example, it'll be more clear. They're telling you, determine whether this is a factor of this. And remember, the whole purpose of the second half of chapter 5 is to factor, right? To get a bunch of parentheses, right? That way, if it were an equation, you could split them and solve. But what I'm saying here is this a factor of this based on this truth? What truth? That if you divide something by its factor, the remainder is 0. That's how you know that this is a factor, okay? So if I have a polynomial in here, and I divide it by a binomial, and the remainder is 0, then this binomial is a factor. If I take a polynomial and divide it by a binomial and you get a remainder, then that binomial is not a factor. Do you understand that? Do I need to slow down or repeat it one more time? Okay. If you have a polynomial in here, imagine many terms, and you divide it by a binomial, and you divide it all out and the remainder is 0, what do you know about this binomial? It's a factor. It's a factor. That's simple. So down here they're asking us, is this a factor of this? I don't know. Let's divide it. If I get a remainder of 0, it is a factor. If I don't get a remainder of 0, then it's not a factor. Okay, so would you guys like to do long division or synthetic division? Synthetic. That's right. Synthetic is faster. Okay, so let's do synthetic division. What are we going to divide this by? X minus 5. So what am I going to plug into the box? 5. That's right. So what are the coefficients here? 1, negative 7, 7, 15. Let's do synthetic division. 1 plus nothing is 1. 5 times 1 is 5. Negative 7 plus 5. Negative 2. Thank you for participating. 5 times negative 2. Negative 10. 7 and negative 10.
Negative 3.
There you go. And 5 times negative 3.
Negative 15.
And what's the remainder? 0. Yay, I'm happy. Why am I happy? Because I just found out that this guy is a factor of this guy. Why? Because the remainder is 0. Just like up here. Is 4 a factor of 12? Yes, because the remainder is 0. Down here, same thing. Is this a factor of this? Yeah, why? Because the remainder is 0. Whenever your remainder is 0, you know it's a factor. So why is that important? This is important because I know that x minus 5 is a factor, and these numbers down here, guys, this will actually produce what we call the depressed polynomial. Yeah, depressed. It's not happy like we are. It's a depressed polynomial. Why is that? Because it used to be strong, power of 3, and now it got weaker. What's the new power? Square, x squared. Okay, so if it's a power of 3, it's going to get depressed, it's going to go down by 1 degree. So that's going to now be an x squared minus 2x minus 3. Now, I'm doing way more than what they asked us for. All they asked us for is this binomial a factor of this? What's the answer? Yes. Why? Because the remainder is 0. That's it. But I'm going to take it a step further on this problem. What am I going to do? I want to take that factor that I already know, that binomial that is a factor. I want to take these numbers and I want to write a depressed polynomial. So this binomial times this trinomial will give us the above cubic polynomial. The question is, could I continue factoring this guy? This is a quadratic trinomial in red where the a value is 1. All you got to do is think what times what is negative 3, that if you combine together is the b value negative 2. Anybody? Say again. What times what is negative 3 that if I combine together is negative 2?
1 and 2? No, 1 and 2.
Negative 3 times positive 1, right? So what does that mean? I could say x with the negative 3, x with the positive 1. That's now the red one factored. And I could put that x minus 5 in the front. Believe it or not, this is the completely factored form of the original cubic polynomial. Okay, so we learned a new vocab word today that we're going to be stressing for the next couple of days, the depressed polynomial, right? These numbers down here give you a depressed polynomial. Why? Because it used to be powerful, power 3, and now it became a power of 2. These are coefficients in front of variables. That last one's always a constant. And then you always could check if you could continue factoring. Now this is a great thing because if I did have f of x equals this stuff and I graphed it on Desmos, it would actually cross at positive 5, at positive 3, and at negative 1. Here's another type of question. This one, they're not asking us, is x minus 2 a factor of this guy? They're telling us this is one of the factors of this. They give you a polynomial, and they give you one of its factors, which is x minus 2. They're telling you this is a factor of the above. Then they say, find the remaining factors. They want you to write every single factor. They want parenthesis times parenthesis times parenthesis a bunch of times. They give you one of them. They tell you this is one of the factors. So what are we going to do here? Well, we know that if this is a factor of this, if I were to divide it, what should my remainder be? 0, right? Again, this is a factor of that. My remainder is going to be 0. Let me prove that to you. What am I going to put inside the synthetic division box? 2. What are my coefficients? 1, negative 2, 4, negative 8, negative 5, 10. No values missing? No, we're good. Okay, let's do this. Wait, let's do this. 1 plus nothing is 1. 2 times 1 is 2. What do I get when I combine? 0. That's weird. Okay, that's fine. And then I go 2 times 0? 0. Okay, and then combine 4 and 0. 4. Okay, and then multiply 2 and 4. 8. Okay, and combine negative 8 and 8. 0 again. Weirder. Multiply 2 times 0? 0. Combine negative 5 and 0? Negative 5. And multiply 2 times negative 5? Negative 10. And what's my remainder? 0. Now that doesn't surprise me. Why not? Because they told me that's a fact. They told me one of the factors is x minus 2. I mean, it better be 0. If it's not 0, I did something wrong, or they're lying to me. This is not a factor. You guys agree with that? Okay. So all I did was verify this is a factor, but more importantly, I could now write my depressed polynomial with these remaining numbers. Okay, so let's write our depressed polynomial. Like we just verified that x minus 2 is a factor. That binomial is a factor of that 5th degree large nasty polynomial. But what new polynomial do we have left over with that's depressed?
X to the 4th.
X to the 4th. Now, do we have x cubed? No, so I'm not even going to write it. But then we do have a plus 4x squared. Do we have a x? No, so I'm not even going to write it. And just minus 5 at the very end, right?
Yes.
So right now, with this depressed polynomial, I now have a quartic trinomial. And of course, the binomial that they gave us to start with, knowing that that's a factor. So the question is, could I continue factoring this red one?
Yes.
So, ladies and gentlemen, if we focus in on this red one, it's a trinomial, and we are used to factoring quadratic trinomials. So, wouldn't it be nice if this were a x squared plus 4x minus 5? Then you could think, what times what is negative 5, that if you combine together is positive 4, and you'd have an x right here and an x right there, right? You guys remember that, factoring? But the thing is, it's not an x squared, it's an x to the 4th. So instead of putting x and x, what am I going to put right here? X squared and x squared. This is where we pretend, we make that quartic look like a quadratic and factor with the same way of thinking, what times what is c, that if you combine together is b. So what times what is negative 5, that if I combine together is positive 4?
Negative 1 and positive 5.
-1 and +5. All right. And let's not forget about that original factor of x minus 2 that they gave us. So far, I've rewritten my 5th degree long, nasty polynomial as this binomial times this quadratic binomial times this quadratic binomial. Question is, could I factor anything further? Because that's what we want. We want all the possible factors. All the actual factors, that is. We could factor the middle one, right? So that one, again, could be factored. What times what is negative 1, that if you combine together is nothing, right? What times what is a c value, that if you combine together is nothing? There's nothing in the middle. Or you could also look at it as a difference of two squares. Square root that, you get x, square root 1, and you get 1. So what do I have? I have the original binomial that they told me was a factor. Then we got x plus 1, x minus 1. And then we got x squared plus 5, which cannot be factored further. Now, if this would have been a difference of two squares, like x squared minus 9 or x squared minus 4, then I'd have to break this down further. This is as far as you could factor it, guys. So we need to get comfortable with using synthetic division to verify that the remainder is 0, to take those bottom numbers to rewrite our depressed polynomial. Now, ladies and gentlemen, why, let me ask you this one more time before we move on to the next one. Why, when I ask you if x minus 2, I mean, we know this is a factor, why do I plug in a plus 2 right here? Why do I think opposite? Exactly right. If you think x minus 2 equals 0 and solve it, it's going to be x equals 2. That's why we actually plug in a 2. Does that make sense? After all, if this is a factor, why do we want a factor? So we could eventually split and solve. So if you had like something times something times something, and one of those somethings is x minus 2, and it's equal to 0, well, you'd have to split it and solve it, and you'd get x equals 2. That's why we plug in a 2. Why am I telling you this? Because over here, we're going to deal for the first time with a binomial that has a number out in front. You guys remember back when we did long division? I said you could use synthetic division, but if your a value, if your leading coefficient's not 1, go with long division, because you might end up with fractions. You guys remember that? So right here, I am going to use synthetic division, but what am I going to plug in that I get out of this binomial, which is supposedly, this is a factor. I know it's a factor. The 2x plus 1, it's a factor of that cubic polynomial function. So if I were to split them all and set them equal to 0, this would be split and set equal to 0. And what would be my actual x value for this binomial that I know is a factor of? It would be negative 1/2, right? If you set 2x plus 1 equal to 0, you're going to get x equals negative 1/2. And this is exactly what we have to plug in into our synthetic division. Is everybody cool with that? Now let's write our leading coefficients, or our coefficients of each term on this third degree polynomial. We have 18, we have 9, we have negative 2, we have negative 1. Let's not be scared of fractions. Let's deal with it. 18 plus nothing is 18. What is negative half times 18? Negative 9. What's negative 9 plus 9, or 9 plus negative 9?
0.
What is negative half times 0?
0.
What's negative 2 plus 0?
Negative 2.
Last but not least, what's negative half times negative 2? 1. Now, I am not surprised that my remainder is 0. Why am I not surprised? Because I know that this is a factor. They told us this is a factor. That means that the remainder has to be 0. So why did I do this? So I could get my depressed polynomial. What's my depressed polynomial going to be?
18x squared.
18x squared. Now, why is it depressed? Because it used to be a third and now became a square. The 18 is just coincidence that stayed the same, right? Actually, no, it's going to be the same right there. But anyways, what's the next term?
Minus 2.
Minus 2. You don't have to put the plus 0x. It'd be pointless to put the plus 0x. So let's put the minus 2 right there. This is my depressed polynomial. And we know that if we took that binomial 2x plus 1 that they gave us, that they told us was a factor, and put it in front of this guy, if I were to distribute combined like terms, I'd get back to my original cubic polynomial. But that's not what they want. What they want is all the factors. Find the factors, find all the other factors. So the question is, could I continue to break this down? They gave us this one. Could I continue to break this down?
Yes.
Yes. What is the first type of factoring you should always try? GCF. So what could you pull out? Bless you. Pull out a 2. What's going to be left over on the inside? 9x squared minus 1. Could you continue factoring that blue difference of 2 squares quadratic binomial? Yes.
Oh.
Remember, difference of 2 perfect square terms. Square root this. What do you get? 3x. Square root this. What do you get? 1. So you're going to have a 3x, a 1, a 3x, a 1. One's going to be a plus, one's going to be a minus. Don't forget about the 2 that's on the outside. So we could completely rewrite this in factored form. We have the 2x plus 1 that they gave us, that they told us was a factor. We also have the 2 that I'm going to put out in front. And we also have the 3x plus 1 and the 3x minus 1. If you were to distribute the 2 and then distribute combined like terms, it would take you back to the original polynomial of 18x to the third plus 9x squared minus 2x minus 1. This is really cool because if this were a equation set equal to 0, I know that my answers will be negative half, negative 1/3, and positive 1/3. Those are the locations of the x-intercepts if you were to graph this cubic polynomial function. Let's take a look at the homework. Ladies and gentlemen, the homework right here is not from the book. It's from worksheet WSP 5.6. So jot this down, please. Actually, you have it printed out. But cross out the 1, the 3, and the 15. All you're doing on the first part of the homework is number 9 and 11. Numbers 9 and 11. And then you're going to 17 through 27 odd. Again, you're doing 9 and 11, and then 17 through 27 odd. So let's go to the actual worksheet. On your worksheet, on the back side of your notes, you just have the solutions. So what you need to do, the reason why I didn't print out the worksheet is because a lot of people need more space than other people. So I want you to actually copy down number 9 in your notebook, do the math. Copy down number 11 in the notebook, do the math. Copy down 17, do the math. That way you have all the space that you need. You're not running out of space. So let's look at number 9. What are the instructions? I would jot this down in your notebook because you don't have this worksheet. The instructions are for you to find f of negative 3 and f of 4. So I need to find f of negative 3. I could, if I wanted to, plug in negative 3, plug in negative 3, plug in negative 3, do all that math, get my answer. Or I could use synthetic substitution and directly plug in negative 3 with the coefficients 1, 3, 2, and negative 50. So as you go down, 1 plus 0 is 1. As you go up, negative 3 times 1 is negative 3. As you go down, you combine. Negative 3 plus 3 is 0. As you go up, you multiply. Negative 3 times 0 is 0. As you go down, you combine. 2 plus 0 is 2. As you go up, you multiply. Negative 3 times 2 is negative 6. the remainder is negative 56. What does this mean? That for my input negative 3, I get the output negative 56. Okay, this has nothing to do with factors. This is just saying plug in negative 3, and you could do it the old school way. Plug in negative 3, negative 3, negative 3, do all that math using PEMDAS. But it's a little faster to use synthetic substitution. Now they also want you to do f of positive 4. But if you actually wanted to see that work, all you got to do is flip over the paper and see your notes, because we did that in our notes. Okay, so I only want you to do number 9 and 11 of plugging in that negative 3 and that positive 4 to practice synthetic substitution. But the real important stuff comes down here, guys. This is where it's important. What do I mean by that? They give you a polynomial and one of its factors. So they give you this cubic polynomial and one of its factors. They want you to find the remaining factors of the polynomial. So they're telling you this x minus 2 is a factor. They tell you that this is a factor of this polynomial. So what does that mean? If this is a factor of this, if I divide this by this, what should my remainder be? 0. It should be 0 if it's a factor. And they're telling us that it is a factor, so our remainder better be 0. Let's actually do that and show that the remainder is 0. What goes inside of the box? 2. And give me the coefficients. 1, 3, negative 6, negative 8. Line. As you go down, you combine 1 plus nothing is 1. As you go up, you multiply. 2 times 1 is 2. As you go down, you combine 3 plus 2 is 5. As you go up, you multiply. 2 times 5 is 10. As you go down, you combine negative 10 and 6, or negative 6 and 10. What do we get? 4. As we go up, multiply. 2 times 4, 8. As we go down, we combine. Negative 8 plus 8, 0. Am I surprised? No. I already knew that if this is a factor, I better get 0 as a remainder. Kind of like if 4 is a factor of 12, 12 divided by 4 is 3. There is no remainder. The remainder is 0. So I know that if this is a factor of this, I better get 0. So I'm not surprised. And this is now where I get my depressed polynomial from. So what's my depressed polynomial going to be? X squared plus 5x plus 4. Now, if this, it's as simple as this. Whatever power you have up here, the depressed polynomial will be 1 degree, 1 power less than that top one. So it's a 3. That's how it becomes a 2 on the depressed polynomial. So this is what we have left over, our depressed polynomial. We did have the original x minus 2 that they gave us. That was a factor. So if I were to distribute and combine like terms, I'll get back to the original. But the question is, could I continue factoring here? They want us to list all the possible factors when we know that this is a factor. So could we continue factoring? What times what is 4 that if you combine together is positive 5? Positive 1 times positive 4. That's right. That is 4. And if you combine them together, it is positive 5. So they say x minus 2 is a factor. Find the other factors. The other factors are x plus 1 and x plus 4. Cool? Should we try another, or do you guys got it? You got it. All right. Let's do it.